when galaxies collide. Merging galaxies. Galaxies are huge collections of stars, gas, and dust, held together by gravity. When galaxies merge, they form a single, larger galaxy. This process is known as a galactic merger. The process of a galactic merger is fascinating. It begins with two or more galaxies slowly approaching each other, their gravity pulling them together. As they interact, they distort and disrupt each other, forming giant tails of stars and gas. Eventually, the two galaxies merge into one, creating a single, larger galaxy. Galactic merger effects. Galactic mergers can have a dramatic effect on the galaxies involved. The merger can cause the two galaxies to lose their shape and form new structures, such as spiral arms and bars. It can also cause the galaxies to form new stars and black holes. The effects of galactic mergers can be observed in nearby galaxies. The most famous example is the antennae galaxies, which are two galaxies in the process of merging. The merger has created a spectacular display of stars and gas, and has formed new stars and black holes. Galactic merger benefits. Galactic mergers can have a number of benefits. The merger can cause the galaxies to form new stars and black holes, which can have a positive effect on the galaxy's evolution. It can also cause the galaxies to form new structures, such as spiral arms and bars, which can have a stabilizing effect. The merger can also cause the galaxies to lose their shape, which can be beneficial in some cases. For example, it can cause the galaxies to lose their gas and dust, which can help them to avoid further mergers and become more stable. Galactic merger hazards. Galactic mergers can also have a number of hazards. The merger can cause the galaxies to form new stars and black holes, which can be dangerous if they are too close to one another. It can also cause the galaxies to lose their shape, which can make them more vulnerable to further mergers. The merger can also cause the galaxies to form new structures, such as spiral arms and bars, which can be unstable and lead to further disruption. In addition, the merger can cause the galaxies to lose their gas and dust, which can be detrimental to the galaxy's evolution. Galactic merger frequency. Galactic mergers are relatively rare events. The Milky Way, for example, is estimated to have merged with only one other galaxy in the past 10 billion years. However, this is not necessarily a bad thing. The low frequency of galactic mergers means that galaxies have more time to evolve and form new structures. The frequency of galactic mergers is expected to increase in the future as galaxies move closer together due to the expansion of the universe. This means that we can expect to see more galactic mergers in the future, and more spectacular displays of stars and gas. The conclusion. Galactic mergers are fascinating events, and can have a dramatic effect on the galaxies involved. They can cause the galaxies to form new stars and black holes, and can cause them to lose their shape and form new structures. We can expect to see more mergers as the universe expands. Now it's time to take a look at a few examples of this courtesy of NASA and their partners. NGC 6052. This image, taken with the Wide-Field Planetary Camera 2 on board the NASA ESA Hubble Space Telescope, shows the galaxy NGC 6052, located around 230 million light-years away in the constellation of Hercules. It would be reasonable to think of this as a single abnormal galaxy, and it was originally classified as such. However, it is in fact a new galaxy in the process of forming. Two separate galaxies have been gradually drawn together, attracted by gravity, and have collided. We now see them merging into a single structure. As the merging process continues, individual stars are thrown out of their original orbits and placed onto entirely new paths, some very distant from the region of the collision itself. Since the stars produce the light we see, the galaxy now appears to have a highly chaotic shape. Eventually, this new galaxy will settle down into a stable shape, which may not resemble either of the two original galaxies. NGC 1487. This image was also taken by NASA and the ESA's Hubble Space Telescope. It shows a peculiar galaxy known as NGC 1487, lying about 30 million light-years away in the constellation of Eridanus. Each progenitor has lost almost all traces of its original appearance, as stars and gas have been thrown hither and thither by gravity in an elaborate cosmic whirl. Unless one is very much bigger than the other, galaxies are always disrupted by the violence of the merging process. As a result, it is very difficult to determine precisely what the original galaxies looked like and, indeed, how many of them were there. In this case, it is possible that we are seeing the merger of several dwarf galaxies that were previously clumped together in a small group. Although older yellow and red stars can be seen in the outer regions of the new galaxy, its appearance is dominated by large areas of bright blue stars, illuminating the patches of gas that gave them life. This burst of star formation was likely triggered by the merging of elements from each. Sparks, 1049 plus 56. A massive cluster of galaxies, called Sparks 1049 plus 56, can be seen in this multi-wavelength view from NASA Hubble and the Spitzer Space Telescopes. At the middle of the picture is the largest, central member of the family of galaxies, the upper right red dot, of the central pair. Unlike other central galaxies in clusters, this one is bursting with the birth of new stars. Scientists say this star birth was triggered by a collision between a smaller galaxy and the giant central galaxy. The smaller galaxy's wispy, shredded parts, called a tidal tail, can be seen coming out below the larger galaxy. Throughout this region are features called beads on a string, which are areas where gas has clumped to form new stars. This type of feeding mechanism for galaxy clusters, where gas from the merging of galaxies is converted to form new stars, is rare. The Hubble data in this image show infrared light with a wavelength of 1 micron in blue and 1.6 microns in green. The Spitzer data show infrared light of 3.6 microns in red. Iris. This delicate smudge in deep space is far more turbulent than it would first appear. Known as Iris, 14348, 14447, a name derived in part from that of its discoverer, the infrared astronomical satellite, IRAS for short. This celestial object is actually a combination of two gas-rich spiral galaxies. This doomed duo approached one another too closely in the past, gravity causing them to affect and tug at each other and slowly, destructively, merge into one. The image was taken by Hubble's Advanced Camera for Surveys, ACS. Almost 95% of the energy emitted by this galaxy is in the far infrared. The huge amount of molecular gas within IRAS 14348-1447 fuels its emission and undergoes a number of dynamical processes as it interacts and moves around. These very same mechanisms are responsible for IRAS 14348-1447's own whirling and ethereal appearance, creating prominent tails and wisps extending away from the main body of the galaxy. SDS-SCGB 10189. A spectacular trio of merging galaxies in the constellation Bootes takes center stage in this image from the NASA ESA Hubble Space Telescope. These three galaxies are set on a collision course and will eventually merge into a single, larger galaxy, distorting one another's spiral structure through mutual gravitational interaction in the process. An unrelated foreground galaxy appears to float serenely near this scene, and the smudged shapes of much more distant galaxies are visible in the background. This colliding trio, known to astronomers as SDS-SCGB 10189, is a relatively rare combination of three large star-forming galaxies lying within only 50,000 light-years of one another. While that might sound like a safe distance for galaxies, that makes them extremely close neighbors. Our own galactic neighbors are much farther away. Andromeda, the nearest large galaxy to the Milky Way, is more than 2.5 million light-years away from Earth. This image comes from an observation designed to help astronomers understand the origin of the largest, most massive galaxies in the universe. These galactic behemoths are called brightest cluster galaxies, BCGs, and, as the name suggests, are defined as the brightest galaxies in any given galaxy cluster. Astronomers suspect that BCGs form through the merger of large, gas-rich galaxies like the one seen here. They turn to Hubble's Wide-Field Camera 3, an advanced camera for surveys, to investigate this galactic trio in painstaking detail, hoping to shed some light on the formation of the universe's most massive galaxies. CGCG 396/2. This NASA ESA Hubble Space Telescope observation has captured the galaxy CGCG 396/2, an unusual multi-armed galaxy merger which lies around 520 million light-years away from Earth in the constellation Orion. This observation is a gem from the Galaxies project, a citizen science project involving hundreds of thousands of volunteers from around the world who classified galaxies to help scientists solve a problem of astronomical proportions. How to sort through the vast amounts of data generated by telescopes. A public vote selected the most astronomically intriguing objects for follow-up observations with HUBBLA CGCG 396/2 is one such object. Imaged here by Hubble's Advanced Camera for Surveys,